The April night of 1986 over Libya is not just dark, it feels like an absolute dead void. At an altitude of 15 miles where the atmosphere becomes so thin that the sky above turns black, a reminder of the proximity of space, Major Brian Schule piloted his SR-71 Blackbird through the hostile silence. This aircraft was always considered something beyond reach, too high for enemy interceptors, too fast for missiles, and nearly invisible to the electronic eyes of radar. In 20 years of service, not a single Blackbird had ever been shot down. But that evening, the perfect machine faltered. Suddenly, the cockpit was flooded with an alarming crimson light. The instrument panel was literally screaming of danger. Old Soviet anti-aircraft systems in Libya had managed the impossible. They locked onto the most elusive machine in history. Due to a series of maneuvers and course corrections, the Blackbird was flying slightly slower than usual, and that brief moment was enough for the enemy to pull the trigger. From below, out of the black abyss, came the fiery trails of missiles. Schule knew any split-second delay, and the legend of invulnerability would turn into burning wreckage in the middle of the desert. The only solution was to jam the throttles all the way forward. No one knew then if the titanium hull could withstand such an extreme acceleration, as the instrument needles were already pushing past Mach 3.5, exceeding the aircraft's official specifications. It was a battle of pure speed against explosives. The missiles never caught the Habu. That incident became the quintessence of the SR-71's entire legacy, a machine that always existed on the edge. But to understand how humanity created a craft capable of literally outrunning incoming missiles, we must go back to the past. To the days when the bird's predecessor plummeted from the sky directly into the hands of the Soviet Union. The geopolitical calm was shattered on May 1st, 1960, when news broke across global media that made Washington tremble. The high-tech Lockheed U-2 spy plane, considered nearly unreachable, was shot down in the heart of the Soviet Union. The pilot, Francis Gary Powers, managed to eject, but instead of finding safety, he fell straight into the hands of the Soviet military. This catastrophe occurred at an altitude of 70,000 feet, a level Americans had grown accustomed to viewing as a zone of absolute safety. Along with the plane's wreckage, years of illusions regarding the impunity of reconnaissance flights came crashing to the ground. Moscow did not miss the chance to stage a public shaming, presenting the world with the salvaged equipment, cameras, and fuselage fragments. While President Eisenhower tried to save face by passing the incident off as a routine weather research flight, the Soviet leadership was already busy displaying the craft's spying hardware. The White House's lie was exposed instantly, turning a diplomatic scandal into a true disaster. Negotiations between the superpowers collapsed, and the Cold War reached its boiling point. However, the primary takeaway was a harsh conclusion drawn in Washington. If a Soviet missile hit a U-2 once, it would hit any other aircraft of a similar type. Overnight, previous methods of aerial reconnaissance became a death trap. America needed something radically new, a machine that would fly so high, so fast, and so stealthily that the very concept of interception would become technically impossible. It was this crisis that served as the catalyst for a project that would change the very essence of aviation. In the shadows of Lockheed's massive hangars in California, there existed a place unknown even to many high-ranking Pentagon officials. This was the Skunk Works division, a kingdom of secrets where the wildest ideas in American aviation were born. It was headed by the legendary Kelly Johnson, a man who did not recognize the word impossible and built aircraft that were decades ahead of their time. The assignment he received from the CIA sounded like technical suicide. Build a machine capable of sustained flight at Mach 3 at an altitude of 80,000 feet. To understand the scale of the task, that is 3 times the speed of sound. At these speeds, air ceases to be a transparent gas and turns into a solid wall, while friction heats the skin to temperatures where standard aircraft aluminum becomes as soft as butter. The government issued a harsh ultimatum. The entire project had to be completed in 2 years. Experts from competing bureaus openly mocked the idea, claiming such a craft would either shake itself apart from violent vibrations or simply turn into a blazing meteor within minutes of takeoff. Utopia, absurdity, engineering fiction, these were the mildest labels thrown at the project. But Johnson operated by his own rules. He assembled a team of fanatics and locked them behind barbed wire in an atmosphere of strict secrecy and creative fever. The project was codenamed Archangel. The very first obstacle on the path to the heavens was a matter of life and death. What on earth could you build a plane out of that was expected to fly in a literal hell? Kelly Johnson faced a physical dead end. At Mach 3, air friction turned the aircraft's skin into a glowing oven. A temperature of 1,000 degrees Fahrenheit is a death sentence for aviation aluminum. It would simply turn into soft mush, losing all structural integrity. The only way out was titanium. In those years, this metal was considered an exotic material, suitable perhaps for small engine components, but certainly not for an entire airframe. Titanium was incredibly strong, light, and heat-resistant, but it had one small problem. There was practically none of it in the United States. And here begins one of the most ironic chapters of the Cold War. The only country possessing vast reserves of titanium ore was the Soviet Union. The CIA had to launch a massive shell game. Through a network of front companies in Europe and around the world, the Americans purchased rutile titanium ore from the Soviets. In essence, the USSR was voluntarily selling the metal that the US used to build its most elusive spy plane for flights over the USSR's own territory. It was a masterclass in cynicism and secrecy, but obtaining the metal was only half the battle. Working with titanium in the 1960s was a living hell. It was so temperamental that standard steel drill bits would snap against it in a second, and the mere touch of a cadmium wrench caused corrosion that would turn apart into dust within a month. In the early stages, Skunk Works threw up to 80% of their workpieces into the scrap bin. Defects were everywhere. Johnson had to reinvent metallurgy, creating new tools, changing the composition of cooling fluids, and even banning workers from using ordinary tap water to rinse parts due to its chlorine content. The Blackbird was born in agony, becoming the most expensive and temperamental model kit in human history. If you were to approach an SR-71 as it sat on the runway, you would think the aircraft was broken. Puddles of fuel were always spreading beneath the fuselage. The machine literally cried kerosene, which seeped through the panel joints. But this was not an engineering error. It was a brilliant calculation. The fact was, Kelly Johnson faced a paradox. At Mach 3, the titanium hull expanded and lengthened by nearly 30 centimeters due to intense friction. If the panels had been fitted tightly on the ground, they would have buckled or torn apart in the sky from thermal expansion. Therefore, the designers left gaps. The Blackbird was leaky in the hangar but became perfectly airtight only when it heated up to a red glow in flight. It was a true technological shapeshifter. Clumsy, dripping, and flimsy on the ground, it found its true form only in the scorching hell of the stratosphere. The aerodynamics were also beyond the understanding of those years. Strange, sharp protrusions appeared along the nose. They were called Chinese. At first glance, they seemed decorative, but at supersonic speeds, these edges created additional lift, allowing the aircraft to literally lean on its own shock waves. Even the fuel tanks here were part of the structure. No internal rubber lining, as any rubber would have turned to coal at 500 degrees. The fuel was in direct contact with the titanium. The Blackbird was not just a plane, but a single, living piece of metal that breathed, expanded, and changed its essence depending on its speed. If the Blackbird's airframe was its body, then the Pratt & Whitney J58 engines were its ferocious heart. These were not just motors. They were complex hybrids capable of transforming right in flight. At low speeds, they functioned like standard turbojets, but once the needle crossed Mach 2, the magic began. Special movable cones on the air intakes, the famous spikes, would retract inward by as much as 60 centimeters. This redirected the airflow around the main turbine, turning the engine into a ramjet. In effect, at peak speed, the aircraft flew on 6 massive blowtorches that literally devoured space. But to prevent this power from turning into an uncontrollable explosion, the strangest fuel in aviation history had to be created. JP7. It was so stable and heavy that you could literally extinguish lit cigarettes in it. It would not ignite. It wouldn't burn from a match or explode from a spark. Igniting it required extreme chemistry. A dose of triethylborane, TEB, a substance that spontaneously combusts upon contact with air, was injected into the system. This is why every engine start of the Bird and every transition to afterburner was accompanied by a spectacular bright green flash from the nozzle. It looked as if the plane were spitting magical fire. Furthermore, this fuel served as a coolant. Before reaching the combustion chamber, the kerosene circulated throughout the entire fuselage, soaking up excess heat from the glowing titanium and the pilot's cockpit. The Blackbird literally survived by drinking its own cold before transforming it into incinerating thrust. When the prototype, designated the A-12, was finally ready, a question arose: where to test a machine whose very existence was a top-tier state secret? The choice fell on a remote stretch of the Nevada desert, the dry salt lake of Groom Lake. Today, the entire world knows this place as Area 51, but back then, it was just a dot on the map surrounded by barbed wire. Transporting the aircraft from California to Nevada turned into a complex special operation. The massive titanium fuselage was disassembled, packed into specially designed crates over 30 meters long, and hauled over public roads under the cover of night. To allow the convoy to pass, engineers had to temporarily dismantle road signs and cut down roadside trees. In early 1962, the Archangel first touched its wheels to the concrete of the desert runway. It wasn't black yet. In the rays of the morning sun, the aircraft shimmered with pure bare titanium. It was a sight from another world, a narrow, predatory silhouette that looked more like a spearhead than a mid-20th century flying machine. The first flights confirmed it. Kelly Johnson wasn't crazy. The machine easily broke the sound barrier, but every flight was a walk on a razor's edge. Test pilots knew that if the slightest glitch in the engine's air intake occurred at such speed, a so-called unstart, the aircraft would experience a jolt so violent the pilot's head could literally smash into the cockpit canopy. Despite the risks, the A-12 proved its viability. But while the CIA celebrated its success, the military was already preparing its own version of this machine, the one that would forever go down in history as the Blackbird. By 1967, the Vietnam War had turned into a technological stalemate, and the Pentagon desperately needed fresh data on the location of Soviet anti-aircraft missiles. Thus began Operation Black Shield. Okinawa, Japan, specifically Kadena Air Base, was chosen as the operating site. It was here that the world first saw the A-12 in action. Although officially, this aircraft still did not exist. The secrecy was pushed to the point of absurdity. Pilots flying missions over Vietnam and North Korea were not technically military personnel. They were listed as CIA employees, flying without documents, without dog tags, and in suits without any identifying insignia. If such a plane had crashed on enemy territory, the U.S. government would have simply stated, "We don't know whose craft that is, and we have no idea who was piloting it." The very first sorties proved the Archangel's total transition to dominance. At an altitude of 25 kilometers, the aircraft was out of reach for Vietnamese MiGs, which hung helplessly far below, unable to even breathe the thin air of the stratosphere. In a single pass, the A-12 could photograph an entire country's territory, producing images of such quality that you could count the stripes on a football field. However, the enemy did not sit idly by. During one mission over North Vietnam, several SR-75 missiles were fired at the aircraft simultaneously. The pilot saw the launch flashes but didn't even maneuver. He simply nudged the throttle forward. After landing, technicians discovered a tiny shrapnel fragment lodged in the titanium skin near the tail. This was the only time the enemy managed to even touch the machine. But the era of the A-12 was drawing to a close. The Air Force's Blackbird was stepping onto the stage. While the CIA successfully operated the single-seat A-12, the military brass at the Pentagon were biting their nails. They wanted their own version of the titanium monster, heavier, with an expanded sensor suite, and most importantly, a second crew member. Thus, the RS-71 reconnaissance strike prototype was born. But it entered history under a different name due to a funny yet fateful blunder. In July 1964, President Lyndon B. Johnson was giving an official speech in which he was to introduce the world to the new top-secret aircraft. His drafts listed it as RS-71, but whether due to a slip of the tongue or a last-minute edit by someone else, the president confidently announced to the entire nation SR-71. His entourage was in shock. Correcting the commander-in-chief on live television was a losing game. It was easier to rewrite thousands of blueprints, update the technical documentation, and swap the labels at the factories. Thus, reconnaissance strike became strategic reconnaissance. It was then that the aircraft acquired its legendary appearance. To solve the overheating problem, it was painted a radical black. This ferrite-based paint not only helped dissipate heat by radiating it into space, but also absorbed radio waves, making the aircraft even more invisible to radar. A second cockpit appeared for the Reconnaissance Systems Officer, RSO. Now, the pilot could focus on taming this headstrong beast while his partner behind him managed the cameras and electronic warfare systems. From the CIA's secret Archangel, the machine finally evolved into the Air Force's Blackbird, the official symbol of American technical superiority, now proudly wearing its nickname. Flying the Blackbird was something between a fighter pilot's mission and a spacewalk. Preparation for it resembled a moon launch. It all began not on the runway, but in the mess hall, where a ritual breakfast awaited the pilots, steak and eggs. This wasn't a whim. A high-protein, low-fiber diet ensured that the body wouldn't require an emergency break during a multi-hour flight. Then came the gear. SR-71 pilots didn't wear standard flight jackets. They donned full-pressure suits, bulky, awkward, and insanely expensive suits that would save their lives if the cockpit depressurized at 80,000 feet. Without this suit, a human's blood would literally boil instantly at that altitude. Inside the cockpit, an atmosphere of technical zen prevailed. Due to the scorching airframe, even the thick quartz glass of the canopy heated up to 300 degrees Celsius. Touching it with a bare hand was impossible. However, the pilots found a practical use for this. They would press their tubes of food against the glass to heat up their lunch. A steak warmed by the edge of space. That was a privilege of the elite. But there was a downside. Pilots sat for hours in a cramped capsule with almost no room to move. Their only window to the world was a narrow view through the glowing quartz, beyond which the sky turned a deep ink blue and the horizon curved distinctly, reminding them that they were among the few humans to see the planet in its entirety. It was a majestic yet haunting loneliness at 2,000 miles per hour. The statistics of the SR-71 sound like a defiance of the laws of physics. Throughout its operational history, approximately 4,000 anti-aircraft missiles were fired at the aircraft. The result? 0 hits. The Blackbird didn't rely on flares or complex electronic countermeasure systems. Its primary and only defense was pure, unbridled speed. The evasion tactic in the pilot's manual was written in a single line. If a missile launch is detected, simply accelerate. While other aircraft performed banking turns to deceive a seekerhead, Blackbird pilots just jammed the throttle. They left the missile behind before its engine could even accelerate it to maximum velocity. At a speed of 1 mile per second, the world below turned into a blurred canvas, and threats became powerless flashes somewhere far behind the tail. One of the most striking records was the flight from New York to London. A standard airliner takes about 7 hours. The supersonic Concorde managed it in 3. The SR-71 did it in 1 hour and 54 minutes. The pilot barely had time to finish his coffee before the shores of Britain appeared under the wing. But there was also a measure of nobility in this race. In 1987, over the Baltic, an engine exploded on an SR-71 mid-flight. The aircraft rapidly lost altitude and speed, becoming an easy target for Soviet air defenses. But instead of finishing off the spy, Swedish pilots in Viggen fighters scrambled and formed a protective ring around the crippled Blackbird, escorting it to a safe zone. It was a rare moment of professional respect in a cold sky where technology usually left no room for sentiment. The bird was too majestic a beast to simply let it fall. Despite all the triumphs, clouds began to gather over the Blackbird that even Mach 3 could not outrun. And the name of this threat wasn't surface-to-air missile, but budget. Maintaining the SR-71 fleet cost the Treasury astronomical sums. A single hour of flight cost up to $200,000, and after every landing the plane required weeks of painstaking maintenance by an army of technicians. In the corridors of the Pentagon, the voices of skeptics grew louder. Why do we need this titanium artifact when spy satellites are hanging in orbit? Satellites didn't risk pilots' lives and could monitor the enemy around the clock. Blackbird supporters countered, "A satellite is predictable, everyone knows its orbit, but the bird is a sudden and daring strike from the stratosphere that delivers images here and now." But in 1989, political maneuverability proved weaker than engineering. The program was officially shuttered. To go out in style on March 6, 1990, the crew of Lieutenant Colonel Ed Yielding made a farewell dash. They flew from Los Angeles to Washington, D.C. in just 67 minutes. In essence, they crossed an entire continent faster than a standard football match lasts. This record remains unbroken to this day. In the mid-90s, there was an attempt to bring the legend back into service under congressional pressure, but its time had passed. The last time the J-58 engines thundered across the landscape was in October 1999 at Edwards Air Force Base. When the titanium giant touched the concrete for the final time, many hardened mechanics and pilots could not hide their tears. The SR-71 didn't leave because it was obsolete or vulnerable. It left because it became too beautiful and expensive for the pragmatic world of the future. Today it stands frozen in museum halls, cold, motionless, yet still looking as if it arrived from another galaxy. A machine that turned pure speed into absolute art.